Hello everyone, Assalamualaikum warahmatullahi wabarakatuh and good day to every one of you. Welcome to my video. So basically this is a lecture video for course code EPO 460. Okay, so in this video we are going to continue our lesson on chapter 5, which is generation, transmission, distribution per unit and also transmission line models. Okay, so here is my name. This is my email address. So you can just feel free to email me whenever you have a question regarding the content of this video. Next, let's have a look at the list of contents that we are going to cover in this chapter. Okay, so basically we are going to divide our chapter into three different parts. So the first part is the generation, transmission and distribution, or we can call it as a GTD. Next, the second part is the per unit system, and the third part is the transmission line models. Okay, so for the first part, which is GTD, so the first subchapter that we are going to go through is the introduction to the power system. Okay, so in this subchapter, we are going to see the definition of the power system, the components inside the power system. Okay, and then after that, we continue with the concept on the generation, transmission and also distribution system. We are going to see what are the types available for the power station in the generation, okay, and then how many types of the transmission line, okay, and then we also see the different type of distribution, and then we are going to follow it with the grid system, okay, and then after that we are going to see the definitions associated with load studies. Okay, finally we are going to see the concept on the single line diagram. Right. Next, the second part of this chapter 5 will be the per unit system. So in this subchapter, we are going to learn on the definition on the per unit system and how to do the calculation and analysis based on the per unit system. Okay, and then finally, the third part of chapter 5 is the transmission line models. Okay, so in this transmission line models, we are going to see three different types of model, which is short line, medium line, and also long. Okay, and then finally we are also going to do analysis on the voltage regulation for transmission line models. All right. Okay, so basically in this video we are only going to cover from subchapter 5.1 until subchapter 5.5 only. All right, so for 5.6 up to 5.8 we are going to cover in our next class. All right. Okay, now let's move to the first subchapter, which is introduction to power system. Okay, so for the electrical power system, figure 1 represent a simple power system, okay, where we have a generation here that consists of power station that generate the electricity, okay, and then we have a power transformer here where we use the power transformer to step up the voltage from generation in order to transmit through the transmission line. Okay, so we have here we have a transmission line. Here we have a transmission substation where here we use the transmission substation to step up the voltage. Okay, and then we also have a transmission line, then up to the distribution substation. Alright, so this is all the components available in the power system. So at the distribution level, also we have a transmission line. We call it as a transmission line at distribution level, okay, and then the purpose of distribution is to distribute the power energy to the end user. Here is the end user. We have a residential consumer, we also have a commercial and industrial business consumer. Okay, so this figure represents a simple power system. So what is the electrical power system? Electrical power system is actually a network of components that designed to transmit and distribute the energy that produced by the generators to location where it is used. Okay, so we need to transmit and distribute the energy that provided by the generation. We need to transmit to the end user here. So here is the user, here is the user, and here is the user. All right, so this is what we call as an electrical power system. And then there are three main characteristics of electricity supply that state here. Okay, so first of all, the electricity cannot be stored in bulk form. So we cannot store the electricity. So that's why the power must be generated continuously so that it meets the demand at a specific voltage and also frequency. Okay, so because we cannot store the electricity in bulk form, so that's why our power generation must continuously generate the power. Okay, and then the next characteristic is when there is increase in the population and there are increase in the industrial expansion in the housing area and etc., the increases will lead to the continuous increase in the demand for power. Okay, so we know the population always increasing. Okay, so there will be always a new housing area opening soon. So that's why it will lead to continuous increase in demand for power. Okay, and then the third characteristic is the power station is usually located near to the resources location. Okay, for example, if you have a hydro power station. So the power station must be located near to the hydropower sources. Okay, so same goes to if you have a coal power station. So the location of the power station must be near to the source of the coal. All right. Okay. And then the system should be designed and managed to deliver the energy with both reliability and economic. Okay, so in order to for design the power system, you must be put into consideration in terms of the reliability and also economic. Okay, however, both requirement, the reliability and also the economic, are often opposed to each other. So it is instructive to look at the reliability first, and then we try to achieve the optimum. Okay, so because we need to achieve both, we need to achieve in terms of the reliability and also economic, but it is impossible to achieve both at the same time. So that's why it is instructive to look at the reliability of the system first. Okay, and then we try to achieve the optimum performance. All right. Okay, for the energy resources, so there are 5 main energy resources that are available that being used to generate the electric energy. Okay, so the 5 main energy consists of coal, right? We have water, we have gas, oil, and also nuclear. All right, so we go through one by one. For the first energy resources, which is coal we consider as the most common source that available in Malaysia especially. Okay, so it is relatively considered as a cheap fuel, right? Fuel. Unfortunately, the coal is considered as the most polluting sources. Okay, so because of this, because it is considered as the most polluting, so we need to add the feature of anti-pollution in order to reduce the pollution to the world. All right, and then coal, we consider as a non-renewable energy. The next energy resources that we have is a water, or we can call it as a hydro. Okay, so for hydro or water is considered as the best source available because it is always available. Okay, and then it's considered as a non-polluting, there is no problem in terms of the pollution. Okay, and then there is no cost for the fuel. All right. Okay, so the third energy resources is the natural gas. For the natural gas, it is a better and cleaner energy source compared to the coal. Okay, the principal disadvantage is it's very hard to transport over the long distance, and it is also considered as a non-renewable energy. The fourth one is the oil. Okay, so if you compare oil to the natural gas, oil is considered as a bit more polluting than the natural gas. However, it is easy to transport over a long distance. However, oil also can consider is much more expensive, and oil also fall under category of non-renewable energy. Okay, and then the last one is the nuclear energy. For nuclear energy also we can consider as a non-polluting, but it's extremely expensive to build. All right, and then the nuclear energy also require elaborate safety system and also expensive training. Okay, but once it is built, okay, even though it is expensive to build, but once it is built, the cost of the fuel is low. All right. Okay, so this is all the 5 energy resources that are available. Okay, so nowadays active research and development has also been carried out for alternative renewable energy resources, okay, such as geothermal, wind, wave, solar, biomass, and etc. However, the renewable energy resources are not yet economical. Okay. Next, we go to the second subchapter, which is generation, transmission, and distribution system, or GTD. Okay, so for the power system, we know power system is usually divided into 3 main parts. First, we have generation. The second one is the transmission, and also we have a distribution. Okay, so here you see this is the generation part. Here is the transmission part. Here is the distribution part. Okay, so here we have a generator. here we have a bus that connect the generator to the transformer, where we have a step-up transformer. So basically, the step-up transformer is used to to increase the voltage from the generation from 11 kV to 132 kV or 275 kV or 325 kV or 500 kV. Okay, and then after that we have a long transmission line that used to transmit the power from the generation to the distribution. Okay, so here we have another transformer to step down the voltage lower to distribution level, where we have a 33 kilovolt or /11 kilovolt. All right, okay. And then we go one by one. We go to the generation part, transmission part, and distribution part. Okay. So next, for the generation part, okay, for the generation system, power supplied by all power stations are based on power demand. Okay. They are usually generated at a voltage between 11 kV and 25 kV. Figure here represent the typical load curve for 24 hours, where we have this axis represent the load demand and this axis represent the time in terms of 24 hours. So here you have maybe 5 o'clock in the morning, here 10 o'clock in the morning, so here 3 o'clock in the evening, here you have a 8 p.m. Alright, okay, so basically the total power fluctuates between the wide limits depending on the time of the day and also depending on the daily activities of the consumer. Okay, so as you might see here, maybe 5 in the morning, the load demand is lower compared to the 10 o'clock in the morning because of more people are alive and more people are awake. Okay, and then more activity are happen here. Okay, and then maybe at 12 o'clock, here, maybe it become lower a bit at 3 o'clock. Okay, all right, and then it become lower during the night time. All right, so the power will be fluctuate depending on the time and also depending on the daily activities. So the demand studies is very important in order to assess and also in order to plan the amount of electricity that need to be generated in order to match the load demand. All right, so this load curve actually give beneficial information to plan for the operation in order to cope with the demand and also in order to achieve the optimum economic operation. Okay, because based on this, we will know which power station need to be turned on. Okay, which power station need to be operate in order to meet the load demand from the end user. All right, so based on the load demand studies, there are 3 types of generating stations that we can divide. All right, so the first one is the base power station, the second one is the intermediate power station, and the third one is the peak power station. Okay, so we go one by one. The first one is the base power station. Okay, so the base load is actually the minimum amount of power that a utility company must make available to its customer. Okay, so for the base power station, it needs to deliver full power continuously. Means that it needs to deliver power 24 hours a day and 365 days a year. So there is no excuse lah, meaning that you cannot shut down the base power station. Okay, and then the base power station considered as the most economical in terms of its operating cost, because you cannot turn off it, so it must make use to be most economical, and then it also will have a high efficiency output and most reliable. Okay, so based on the studies on the load demand, we can divide our generating stations to 3 different types. Okay, so first one we have base power station. The next one is the intermediate power station. And the third one is the peak power station. Okay, so let's have a look one by one. First of all, we have a base power station. So what does it means by base? So base load is actually the minimum amount of power that a utility company must make available to its customer. Okay, so for the base power station, it will deliver full power continuously. Okay, meaning that 24 hours a day and 365 days a year. So non-stop, meaning that no time for shutdown. Okay, so the base power station must be on continuously. All right, and then for the base power station, it must be the most economical in terms of operating cost, meaning that it must have a high efficiency output and the most reliable. Okay, most reliable meaning that you cannot turn off the base power station. So that's why you must make sure the type of base power station is the most reliable. Okay, so basically, we can use nuclear and also coal-fired station as a base power station. Okay. Next, the second one, we have intermediate power station. Okay, so for the intermediate power station, it can respond to changes in demand relatively quickly, usually by adding or removing one or more generating units. Okay, so basically for the intermediate power station, it operates mainly during the daytime to complement to the base station. Okay, so different with the base station is operate continuously, meaning that no time for shutdown. But for the intermediate power station, it only operate during the daytime. Okay, so for the intermediate power station, it has the most economical in terms of production cost, although it is unreliable in terms of actual energy output. Okay, so for example, we can use hydropower station to be used for intermediate power station. Okay, and then the last one is the peak power station. So for peak power station, it generally run only when there is a high demand, or we call as a peak demand. Okay, and then it also deliver power for short intervals during the day. Okay, so meaning that for case of base power station, you know that base power station it must be operates continuously. Okay, for intermediate power station, it operate mainly during the daytime, but for the peak power station, it operates only during the short interval times during the day. All right. And then the peak power station also must be able to respond very quickly and also can be started up in a few minutes only. Okay. And then peak power station also have high operating costs due to their idling time and due to unutilized capital costs. But it is necessary for optimal operation of power system. Okay, so for example, we can use gas turbine to be used for peak power station. All right, okay. And then next we go to the transmission system. So the next part of the GTD is the transmission system. So the transmission system consists of transmission line and also substation. So the transmission line mostly use three-phase alternating current, AC three-phase. Okay, so commonly there are three types of AC power lines that we divide according to their voltage class. Okay, so we have low voltage line, we have medium voltage line, and we also have high voltage line. So for low voltage line, the voltage will be around 240 volt single phase or 415 volt three phase. Okay, so basically this low voltage line is used for residential use. Okay, and then we also have a medium voltage line which is 3.3 kV and 33 kV. So this is used for distribution level at the transmission line that go to the industrial building. Okay, and then the third one is the high voltage line, which is 132 kV to 500 kV. So basically this is mainly used at the transmission level. Okay, and we also have high voltage direct current HVDC technology. Okay, so for HVDC, it is used for very long distance, typically greater than 600 kilometer, and also is used for undersea cables. Okay, and then we also use HVDC for connecting the two AC networks that are not synchronized. So for example, if you want to connect the network between Malaysia and Thailand, then you need to use the HVDC technology. All right. So, and then one more thing, the substation. Okay, so because we know the transmission system consists of transmission line and also substation, so we need to know the definition of the substation. Okay, so the substation Substation is actually a subsidiary station of the power system where the voltage is transformed from high to low or low to high using transformer. Okay, so that's why in the substation is where we put the transformer. Okay, all right. So there are three types of substation that normally use. Okay, so the first one is the transmission substation. And then the second one is the distribution substation. And then the third one is the interconnecting substation. Okay, so we go one by one. For the transmission substation, it will convert the voltage to extremely high voltage for a long distance transmission. Okay, so why we need to use the extremely high voltage? It is due to, in order to minimize the losses and also to reduce the cost. So that's why, in order from the generation, in order to transmit the power, we need to convert the voltage from low voltage to extremely high voltage. Okay, the second one is the distribution substation. At the distribution substation level, we need to step down the voltage to distribution level. So from high voltage, we need to step down first in order to distribute to the end user. Alright, and then the third one is the interconnecting substation. For the interconnecting substation, we used to connect different power system. Okay, for example, if you want to connect between the Malaysian grid and the Thailand grid, so you need to use the interconnecting substation. The purpose of the interconnecting substation is to enable the power exchange between the two different power systems and also to increase the stability of the overall network. Okay, all right. And then next, we go to the distribution system. Okay, so for the distribution system, it means that we need to distribute power to the consumer. Okay, so when we need to distribute the power to the consumer, meaning that we need to lower down the voltage network first. Okay, so the medium voltage distribution is at 33 kV and below. Okay, for example, maybe it can be 11 kV, it can be 6.6 kV or 3.3 kV. Okay, so the final consumer, which is usually for residential area, utilize 415 volt three phase and also 240 volt single phase. Okay, so normally for the normal single story house, we can use 240 volt single phase. Okay, so maybe for a larger house such as bungalow, maybe we can use, it can utilize 415 volt three phase. Okay, there are two types of distribution network that are available. First one is the radial network and the other one is the ring network. Okay, so let's go one by one. What does it mean by radial network and also ring network? Okay, so first one we have a radial network. So this is this figure represent the radial network where you have a main supply, main intake. Okay, and then you have a bus bar, and then one single line will be connected to many load. Okay, you have load 1, load 2, load 3, load 4, load 5, and load 6. Okay, so for the radial network, it is used to feed power to high-rise building such as shopping complex and also campus. Okay, so for example, maybe you have a supply main intake from here, and then it will be delivered to the maybe ground floor, level 1, level 2, level 3, and so on. Alright, so in terms of the initial cost, the radial network is cheaper, but it may become unreliable when interrupted. Okay, meaning that when there is a power disturbance, so it may affect the whole load. Okay, alright, so any interaction has to be dealt immediately and the system need to be restored to its full operating function before the supply could be made available. So meaning that for example, let's say you have a fault here. So every single floor in the building will get impacted. Okay, so you need to deal with the interruption as soon as possible so that the supply can be sent to all the load. Alright, okay. And then next we have ring network or interconnected network. Okay, so figure 5 represent the ring network. Okay, so where, for example, here you have a supply main intake. Okay, so the supply main intake will be sent to different load. So here we have load, here also we have load. Okay, all right. So for the ring network, it allows the rerouting of the power flow in the event of breakdown. Okay, meaning that, for example, in the normal operation, maybe you have one load here, the supply main intake here, we supply to this load, and this load. Okay, let's say in the event of breakdown of this transmission line, okay, so there is no power flow, we go through here, but okay, this load can also receive the power from the other flow. Okay, so maybe fault happen here, but the power can flow here to here, here, and go to here. Okay, so that's why, what does it mean by it can reroute the power flow? And with careful planning, any failures will result in minimal interruption to the consumer. Okay, next we go to the third subchapter, which is the grid system. Okay, for the grid system actually represent the overall network that consists of many interconnected power system. Okay, previously we learned about the power system. We know that the power system consists of generation, transmission, and distribution. Okay, so if you have many power system, you can interconnect the power system together by using the grid system. Okay, so the advantage of using the grid system are in terms of the stability operation. Okay, so the system will have greater reserve power through their combined resources than a system working in isolation, meaning that when you have two different power system or three different power system working together, you can combine the resources. Okay, so when you combine the resources, you have greater reserve power. Therefore, the system will be able to withstand a large disturbance and is more stable. Okay, and the stability will also increase with an increase in number of stations. So the more station you have, the more stable it will be. Okay, and then the second advantage is in terms of service continuity. Okay, so let's say if you have one of the generating station is breakdown or maybe have a failure, or you need to close for inspection and repair, the energy could be still can be supplied from the remaining station. So for example, in the grid system, maybe you have three different station. Okay, so if one station is breakdown, but the consumer still can get the energy because we can supply from the remaining station. Okay, and then the third advantage is in terms of the economy. Okay, so in the grid system, the load can be shared among various generating stations so that the overall operating cost can be minimized. Okay, because we have many generating stations instead of one only, so the load also can be shared. Okay, so we can shut down a number of stations when the demand is low. Okay, so that's why when you have a grid, let's say you have three different stations. Okay, when the demand is low, maybe you can just turn on one station only rather than you turn all those three stations. Okay, all right. So in Peninsular Malaysia, the power grid is known as the national grid. Okay, so the national grid is operated and owned by Tenaga Nasional Berhad. Okay, and then the national grid spans the whole of the Peninsular Malaysia and connecting the electricity generating station owned by the TNB and also by independent power producer, or we can call it as a IPP. And then there are two other electrical grids in Sabah and Sarawak. Okay, so in Sabah, the electrical grid is operated by Sabah Electricity Sdn Bhd, and in Sarawak, the electrical grids are operated by Sarawak Electricity Supply Corporation. Alright? Okay, so that's all for topics on the grid system. Next, we go to the subchapter of definition associated with load studies. Okay, as a power system engineer, you must be able to analyze the performance of the power systems. Okay, both in normal operating condition and also under fault condition. Okay, so under the normal operating condition, the analysis of power system is known as the power flow study, or we can also call it as a load flow study. Okay, so the power flow study essentially is very important and it is necessary for planning, for economic scheduling, for control, and also for future expansion of the power system. Okay, so that's why you need to understand the power flow study in order to do all these things. All right. Okay. So in a power station, several generators are operated in parallel in the power grid to provide to the total power needed. Okay. So the power station are connected to a common point we call as a bus. Okay. So there are four quantities are associated with each of the bus. Okay, so we have the first one is the voltage magnitude. The second one is the phase angle. The third one is the real power, and the fourth one is the reactive power. Okay, so this is the V. Phase angle, usually we call it as the delta. Okay, and then we have real power, which is P, and we have reactive power, which is Q. All right. Okay, so the system buses are generally classified into three different types. Okay, so we have load bus, we also have a generator bus, and we also have a slack bus, or we can call it as a swing bus. Okay, so we go one by one. For the load bus we also known as a PQ bus. Okay, so where you have PQ, meaning that the specified value is the real power P and also reactive power. Okay, so whenever you have the information on the real power and reactive power, you call it as a PQ bus. Okay, so the second bus is the generator bus, or we also known as a PV bus. Okay, so P and V meaning that the information on the real power P and also on the bus voltage magnitude V is available, so we call it as a PV bus or generator bus. Okay, and then the third one is the slack bus or swing bus. For slack bus or swing bus, the information available is in terms of magnitude of the voltage and also the phase angle of the voltage. Okay, so slack bus also serve as a reference bus for the power system. All right. Next, we go to the subchapter of single line diagram. Okay, so one line diagram or single line diagram. So both represent the same things. Power systems are usually represented by one line diagram. Okay, meaning that it is represented by a single line that represent the three-phase connecting power system components together. So usually, if you have a three-phase, okay, so the three-phase diagram will be more complicated. So we can represent the three-phase power system into a single line that represent the three-phase. All right. So the one-line diagram is a combination of the standard set of symbols for electrical components, such as one-line diagram provide a compact way to represent the information. Okay, so this is the symbols that used in the power system of one-line diagram. Okay, so usually when you have a circle like this, it represents the rotating machine, maybe your generator. Okay, so for example, for if you have a synchronous machine, okay, for your generator, so you can represent by a round shape. Okay, so here and here is the power transformer. So here you have a 2-winding transformer. Here you have 3-winding transformer. Okay, so this symbol represent the fuse. Okay, so this symbol represent your current transformer. This symbol represent your potential transformer or your voltage transformer. Okay, so this is your oil circuit breaker or liquid circuit breaker. Okay, and then if you have a air circuit breaker, you can represent by this symbol. Okay, so this represent the delta connection of your machine, okay, or your transformer maybe. And then this represent the Y connection. Okay, here also Y connection. The difference between here and here is this is Y connection with neutral ungrounded, but here you have a Y connection with neutral grounded, right? Okay, so this is all the symbols that we always use when we want to draw our power system in terms of the one line diagram. Okay, all right. For example, if you have this diagram, okay, so you have a figure 2 represent a one line diagram of a simple power system. Okay, and then based on the diagram, you can see that it contains of two synchronous machine. Okay, so this is your first machine, this is your second machine. You see, this is a round shape. Okay, round shape represent the rotating machine. So this is your generator lah. All right. Okay, and then it also have two loads also. Loads usually represent by arrow here. Okay, so you have load A, load B. Okay, two loads, and then you have two buses. Okay, so this is the first bus, this is the second bus, and then you also have a two transformer. So this is the first transformer, second transformer. Okay, so the first transformer have a Y connection and Y delta connection. You also have a transmission line, meaning that I have a single transmission line here. Okay, can and then you also have a several oil circuit breaker to protect all the device. Okay, so here is the circuit breaker 1, 2, 3, 4, 5, 6, 7, and 8. Okay, so the purpose of circuit breaker is to provide the each of the device. So this device is protected by this circuit breaker. This load is protected by this circuit breaker. Same goes to this circuit breaker and also this circuit breaker. Okay, so basically for the power transformer is protected by this circuit breaker and also this circuit breaker. Okay, so you note that in this diagram it also indicates the type of connection for each of the machine and the transformer. Okay, so here it indicates the type of connection of the transformer. You have star star. Here you also have a star connection. This machine also have a star connection. Okay, all right. A one-line diagram also usually used to include additional information such as the rating of the machine and rating of the transformer, and also the power that being consumed or supplied by all the loads in the system, and also the impedance of various devices in the system. Okay, so some of the diagram might have information on the rating of the machine. Okay, maybe it can put the value here, 50 MVA maybe. Okay, so for the load, maybe how many power that consumed by the load. Okay, so usually it will put additional information here. All right. Okay. Okay, so that's all for topics on one line diagram. Okay, so for next per unit system, we will cover in our upcoming class. Okay, so thank you for your time. Thank you for watching my video. I'll see you in the next class. Okay, bye.